What's up, people? Happy Friday, and welcome to our summary for week 2 in Math 8. Let's go ahead and get started here. First of all, when we're talking about transformations, these translations, rotations, and reflections, we started off talking about them by themselves. So we translated something or we reflected something. We now are going to start talking about this thing called sequence of transformations, just meaning we take our original figure and then we do multiple transformations to then move it to our final image. Often when we talk about, transforming things, we label it and our image has a symbol that looks like an apostrophe, or we pronounce it A prime. For a translation, when we're describing translations, we always talk about corresponding points. We take it from A to A prime or D to D prime. We also like to talk about the distance and the direction. So in this case here, if we were going to take it from A to A prime, we would go 1, 2, 3, 4 units to the right and 1 unit down when we're describing the translation on this grid. For a rotation, we always talk about the angle that it's rotating and where the center of rotation is. In this case here, if we're starting with this polygon, this hexagon ABCDEF, it's rotating counterclockwise, that's the direction, using the center P. And then we show our image with all of these A, B, C, D, E, F primes. For a reflection, we always just describe it by the line of reflection, or where we mirror our image. In this case here, each point is mirrored across this line, and again we use the apostrophe to show that it's A and then A prime in our image. When we're describing transformations, we often use coordinates on a coordinate plane. So in this case here, you can see that A and B are labeled with the coordinates. When we make our translation, we can see the new A prime and B prime of our image. When we're talking about how it's being translated, we often say it's being translated right 3 and down 2 because we can see going from B to B prime, we're going right 3 units and down 2. When we're reflecting across an axis, well, we usually just change the sign of one of the coordinates. So if we're starting on A prime or A here and flipping over the x-axis, you see that we keep the same numbers, but we just flip the sign of the y coordinate. If we're flipping it over the y-axis, you see that we keeping the same numbers, but flipping the sign of the x coordinate. So the last thing that I want to talk about, and it's super important here, is this idea of rigid transformations. All three of the transformations we've talked about, translations, reflections, and rotations, are all rigid transformations, which mean that our original figure and our image are congruent. And this idea of congruency is just meaning that our original image and the corresponding side lengths and angle measures are equal. Let me repeat that because, again, it's super important. In these corresponding sides and corresponding angles of rigid transformations, they are always going to be equal. So if you see this image here, all of the angles and their corresponding angles are the same. All of the sides and the corresponding sides are the same. So rigid transformations create a congruent figure. That's all I got for you. Great work this week. If you have any questions, let me know. Otherwise, be good to each other, and I'll talk to you all soon.